is basically simply assessing the quality of the tablets that you have manufactured to see if they meet the required specifications before they can be packaged for marketing. So there are a number of things that we have to look at. The prepared tablets must meet physical specification and quality standards according to the monograph of the pharmacopeia. So there are different pharmacopeias that are available for use depending on where you are and the preference for that country. So you have for the United States pharmacopeia, you've got the British pharmacopeia, you've got the Chinese pharmacopeia, you've got the European pharmacopeia, the Indian pharmacopeia, international pharmacopeia, and so on. So those pharmacopeias are going to specify the quality standards that the tablets must meet for it to be allowed on the market. In general, a number of things are looked at. You have to look at the weight and its variation. You have to look at the content uniformity. You look at the thickness of the tablet, the hardness of the tablet, friability of the tablet, disintegration, and dissolution as well. So in general, these are the parameters that you are going to focus on. There could be other parameters that you might need to consider. If, for example, you begin to have a look at coated tablets, other things might need to come in for you to evaluate. But in general, these will be your focus. So these factors must be controlled during tablet production, which is what we refer to as the in-process control. And then they are validated after the production to ensure quality standards. I think I did talk about these processes as part of standard operating procedures during manufacturing. You'll be taking some tablets and then assess those tablets for a number of these factors we have listed. And then you want to do the same after the production is complete. You see if the tablets still comply with the specifications you stated. So let's have a look at these tests one by one for now. So we start with disintegration. As the name is suggesting, this is when the tablet is broken apart. Okay, once it gets into GI fluids or disintegration testing fluids, you want the tablet to disintegrate. If there is no disintegration, then the process of dissolution is not going to take place. Okay, so for drug, for the active ingredient to get into solution, it must first of all disintegrate. So immediate release tablets should be readily disintegrated in the stomach when they are swallowed. So this basically involves bursting apart of the compact masses. Those compact masses that you produce, called the tablets, they burst apart by aqueous fluid penetrating the fine pore structure of the tablet. So the absorption of the fluids into this compact mass results in the entire structure bursting apart. This is an important test in process control testing to ensure batch to batch uniformity. You want to ensure that all the tablets that you are manufacturing disintegrating within a specified period. Okay. Its role in end product testing has been largely superseded by dissolution testing. So in most cases, this is only being very important in process as an in-process control. But at the end, for you to validate the quality of the tablets, mostly we are using the dissolution test. So in general, the tablet must first disintegrate and discharge the drug to body fluids for dissolution and for absorption to occur. Okay, if the tablet doesn't disintegrate, then there isn't going to be dissolution. And if there is no dissolution, then the drug is not going to be absorbed. And if there is no absorption, you are not going to have any therapeutic or pharmacological response. So the general manner in which a tablet disintegrates is as follows. So there's mechanisms that have been suggested as to how the drug disintegrates. First of all, there's going to be wetting down of the tablet. So when it gets into contact with the fluids, it's going to be wetted down. Then the dissolution liquid penetrates the pore space. Okay, so during the process of wetting, the next thing is, instead of just the fluid wetting the outside of the tablet, that liquid will then penetrate into the pore spaces that are present in the tablet. The disintegrant that you embedded in the tablet is going to absorb water and swells. Okay, if you remember, one of the characteristics of disintegrants or the mechanisms by which they bring about disintegration is that they are able to absorb water and they swell. The swelling is what causes the tablet to break down into granules. So in essence, this is what we are referring to. If you are talking about solid dosage form, first of all, you are going to have a disintegration taking place. This is where we are. Okay, so this disintegration is where you are going to be producing granules or aggregates, small particles from the solid dosage forms. And then there's going to be deaggregation into primary drug particles. At this point, you have dissolution taking place. That is, the drug is now getting into solution. There's also a possibility that the drug can convert into a solution straight from the solid dosage form. But this is limited to the drug particles that are on the surface of the tablet. So once you have the drug in solution, that's when you are going to have absorption there. And then once absorption takes place, then you can have the drug in body fluids and tissues getting to the site of action for them to interact with the receptors for you to have the pharmacological response. So disintegration is the important first step in dissolution of the drug, as we have seen. That is for immediate release tablets. Without this process, we cannot have dissolution taking place. Dissolution is more meaningful in case of many modified release products. So we see that if you start dealing with products such as sustained release products, here, for sustained release products, which we don't require to disintegrate, in fact, these shouldn't disintegrate. So as a measure of drug release, we use the dissolution process. So there are a number of factors that can affect these two processes we are talking about, disintegration and dissolution, which are related in a way. Some of them will include the particle size of the drug substance in the formulation. We know that if you decrease the particle size, you are going to increase the surface area, okay? And if you increase the surface area, you can increase the rate of dissolution. Then the solubility and the hygroscopicity of the formulation. If formulation is highly soluble, it's likely to attract water and can easily get into solution. And so the disintegration and the dissolution will be higher. Other things you can consider is the type and concentration of the disintegrant. We did talk about the roles of these excipients, disintegrant, binder, and lubricant, which you use. So the type and the concentration are going to be affecting the rate of disintegration and dissolution. So if, for example, you use for disintegrants, you have a general rule that if you use higher concentration of disintegrant, the rate of disintegration is going to be high. If you use, we talk about the type, if you use the super disintegrants, that is also likely to increase the rate of disintegration and dissolution. With the binder as well, we know that if you increase the concentration of the binder, this is going to strengthen the cohesive forces in between the components of the tablet. As a result, you expect that if you increase the concentration of the binder, the rate of disintegration must decrease, and also the rate of dissolution will also be decreased. Then if you talk about the lubricant, we did mention that if you are dealing with the hydrophobic lubricants, if you increase the concentration, you are going to increase the hydrophobicity of the formulation. And so it will not be able to attract water, resulting in retardation of disintegration and dissolution. Other factors that you have to think about is the manufacturing method, particularly the compactness of the granulation and the compression force used in tablet. So which method you are going to use can dictate how fast the tablet is likely to disintegrate. If you use granulation method, mostly tablets manufactured by granulation method have got higher dissolution and disintegration rates. If you use a very high compression force, you are going to form very hard structures. As a result, you are going to have reduced disintegration. So it is important for batch-to-batch consistency to establish disintegration and dissolution standards and controls for both materials and processes. So you have to look at the entire process as a whole, starting from the materials that you are using, as well as the processes that you are going to use, the granulation process, the direct compression, what forces you are going to use. You must consider this as a whole, and you must validate your method based on those processes and materials. So tablet disintegration is also important for those tablets containing medicinal agents such as antacids and antiareas. These are not intended to be absorbed, but they act locally. Okay, so once they disintegrate, they are then going to provide an increased surface area for localized activity within the GIT as antacids and antiareas. Okay, so as the water penetration force increases, the tablet disintegration force also increases, resulting in shorter disintegration time. So the amount of disintegrant in the tablet also affects the disintegration. We've talked about this. If you increase tablet pressure, you increase the disintegration time. At very low pressures, you have a lot of pores within the tablet. As a result, the penetration of the liquid is virtually unhindered. So once pores are sufficiently, once the pores are sufficiently small, penetration of the liquid into the disintegrant becomes the limiting step, and disintegration time will increase with increasing pressure. Okay, so most of these, I think they are quite repeating. Disintegrants and lubricants. We've talked about the effect of lubricants on disintegration. Disintegration time increases as the amount of hydrophobic lubricant increases. We've given the reasoning behind. If disintegration is not satisfactory, numerous types of disintegrants are added to the tablet formulation. So if you find that you're having problems with disintegration, then you can either consider increasing the concentration of the disintegrant, or you can switch to different types of disintegrant. Okay. In general, the swelling rate and water uptake are the most important properties of disintegrants. So if you want to have effective disintegration, you need to have a look at the materials that swell and take water quite easily. So what well, the testing of these tablets, disintegration test, we conduct the test in what we refer to as the disintegration testing apparatus. So in here, we use 6 tablets which are placed within these vessels that you can see here in this diagram, is this figure. So you put the tablets in these vessels. In these vessels, you are going to put disintegration medium or dissolution medium, which is representative of the environment where those tablets are expected to disintegrate. So for example, if you'd want to know whether the tablets are going to disintegrate within the stomach, you are going to make a buffer with a pH that is representing the pH of the stomach. Advanced testing might also suggest that you can include even other materials such as enzymes in here to mimic exactly what is happening in the stomach. Okay, so once you put these tablets in the vessels and in the dissolution fluid, then you begin to count the time. You'll see there are also rods that are going to be providing agitation within these beakers. So the agitation is expected to give a force that can also increase the rate of disintegration. This agitation is also representative of the movements that happen within the stomach. So what are some of the things that you must do and what you'll be observing? So if you are dealing with uncoated tablets, or buccal tablets or sublingual tablets, the water is maintained at 37 degrees Celsius. So that dissolution fluid I'm talking about is going to be maintained at 37 degrees Celsius. This is representative of the body temperature. So for these tests, complete disintegration is defined as the state in which any residue of the unit, except fragments of insoluble coating or capsule shell, remaining on the screen of the test apparatus, is a soft mass having no palpably firm core. So you are going to define disintegration as a point where the tablets you started with are simply a soft mass and there is no firm core within that tablet. Okay. At that point, it doesn't matter whether you are seeing fragments all over the place. The tablet can simply remain as a complete structure, but it is soft. If it is soft and you cannot feel any firm core within, then you consider that those tablets have disintegrated. Okay. So buccal tablets must disintegrate within the time set forth in the individual monograph. So for each of these tablets, the monograph in the pharmacopeia will tell you that this sort of tablet should disintegrate within a short period of time and specify within 30 minutes, for example. But they do vary from about 2 minutes for nitroglycerin tablets for up to 4 hours. So depending on the types of tablets you are dealing with, you'll be notified that the time you must check whether the tablets have disintegrated is this. At that time, you go back to the tablets, you stop the apparatus, and then you check whether what you have is a soft mass or it's a complete disintegration. If it's a soft mass, you check whether there is a firm core or not. So if in case you find that one of those 6 tablets fail to disintegrate, then you must conduct additional tests which are prescribed by the USP, for example. Okay? So for example, if 1 or 2 of the 6 tablets fails to disintegrate completely, disintegration testing is repeated on 12 additional tablets. So if a batch fails, one of the tablets you are looking at fails disintegration test, then you are going to take 12 additional tablets. These 12 additional tablets, and you conduct disintegration testing on them. And the understanding then, the guidance is that from those total of 18, not less than 16 of the total 18 tablets tested must disintegrate if you are going to say the tablets have passed the disintegration test. Okay, so we see that the margins are very narrow here. If you just have one tablet failing the test, then you conduct another test. You must ensure that none of those additional tablets that you are going to bring on board for further testing fail. If they fail, then you will have wasted the materials. You have to discard the batch. There's no other way. So you will have spent time and money on something that is not worth it taking to the market. The other thing that you have a look at is what we refer to as weight variation. Do I have a question on disintegration before I move on?
Yes, sir.
Yes.
On you said for you to choose to check if the
yes, sir, I have a question.
Oh.
One at a time. One at a time.
Okay, sir. You said the swelling is one of the factors that you use for you to check the disintegration. But what of those disintegrants which do not use swelling but use capillary action for
Get it a dissolution. You said once it's soft, then
Okay, I've got 2 people talking.
Hello?
I've got 2 people talking. So can you please, is it that you guys can't see when your friend is talking? Let's start with the Moswatile.
Okay, sir. My question is on you said the swelling rate is one of the things that you have to check when choosing the disintegrant. But what do you consider when, or is it just the disintegrants which use swelling for tablets to break down that you consider only, or even those that use capillary action for causing breaking down of the tablets?
Yeah, so it depends on various factors are going to be considered. So depending on other circumstances, could be interaction between the excipients and so on. You can use other mechanisms or the characteristics of the final product that you are looking for. So if you are producing just the standard tablets, mostly we simply look out for disintegrants, which give us the swelling characteristics. You must know that there isn't just one mechanism in which disintegrants work. even during the swelling process, as water moves through the pores within the tablet, you are going to be having creation of pores, which is more of capillary action. Then if you are going to be manufacturing things as dispersible tablets or effervescent tablets, you can consider other disintegrants. And in such cases, you have to find the ratio between the components, the bicarbonate, and also the acid. That gives you a maximum generation of the carbon dioxide to give you the desired disintegration once the tablet is in order. So there are various mechanisms that are available, yes. And which ones you are going to choose will be dependent on the characteristics of the tablets that you are looking at.
Okay. Another question, sir. Sorry. When last time we were looking at solubility analysis when we are doing the formulation, you said when considering the solubility of a substance, you have to subject them to the two different temperatures that we use, 4 degrees Celsius and 37 degrees Celsius, which is the body temperature, considering that those drugs which are enteric. Now, when you are considering disintegration, like we are from doing, do we also consider the temperatures, like subjecting the tablet to the 4 degrees Celsius to consider their physical stability?
No. In this case, we only consider the temperature of the environment where the tablet is supposed to disintegrate.
Okay.
Yeah. I had another question. Although the other person who was asking, the line was quite bad. If you can get me, please ask. Okay, in the meantime, I'll proceed.
Oh, yeah, it was me, sir.
Yes, Christopher.
Yeah, I didn't get you clear on disintegration like of the tablet. When you mentioned like once it's soft, then it's considered to have disintegrated. I didn't get you clear there.
Oh yes, so the term itself, disintegration, might seem to suggest that you need the tablet to completely fall apart and you have different, a number of pieces lying around. But when you are doing the test, you must recognize that if you put the tablet in the disintegration fluid or dissolution fluid, after a period of time, if you cannot find any particles around, as the tablet doesn't appear to have broken apart, you simply check whether you've got a soft mass of that tablet. If you have a soft mass and you do not feel any hard components within the tablet, then you must consider that that tablet has disintegrated. That's the standard rule in disintegration testing. Okay.
Okay, sir, thanks.
I've got a question too, sir.
Okay, that's Peter.
Yes, sir. Mine is on the number of tablets that you need to consider for you to redo the. Okay, let me just say, when you said when you do.
Your line is bad. Peter, your line is bad.
Disintegration test on 6 tablets, and then you discover that.
Okay, let me just repeat that part. The line is very bad.
Passing the test, then you need to go to, you need to redo the testing on 12 tablets. So how many tablets are you supposed to consider?
Okay, so when you are looking at disintegration, you start with 6 tablets. Okay, those 6 tablets, you must observe whether all of them pass the disintegration. The standard rule is that all the tablets must disintegrate within the disintegration testing time that is prescribed. But if you find that one of the tablets hasn't passed the disintegration test, you are going to take 12 tablets. So 12 plus the initial 6 will then make a total of 18 tablets. So when you assess the disintegration of those 12 additional tablets, you must then stick to the rule that at least 16 out of the total 18 tablets tested must disintegrate. If you've got 16 of them disintegrating, then that batch will have passed the disintegration test. If, however, you have less than 16, then that batch will have failed the disintegration test. So the implication here is that from the 12 additional tablets you are going to use, you can only afford to have 1 tablet failing the disintegration test. That's all. That's the limit that you have. Okay, so the network is going to cut, the meeting will be cut, then just please come back. We can have another 10 minutes or so for me to have a look at another parameter, which will be weight variation. Please confirm you are able to get me.
Yes, sir.
Okay. Yes, sir. Okay.
Okay. Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay, yeah. So I want us to look at the next parameter that you must assess. We look at weight variation. So we understand that the weight of the tablet also indicates how much of the active ingredient is likely to be in that tablet. And so it's important that you ensure that the tablets are within a specified weight limit. This is even extremely important if you are dealing with drugs that have got narrow therapeutic indices. Any significant variation in weight from one tablet to another might elicit different pharmacological actions. So during production, some tablets are periodically removed for visual inspection and automated physical measurement. This is during in-process testing or control. Then the USP provides some guidelines for weight variation. So in the test, 10 uncoated tablets are weighed individually and the average weight is calculated. So you are going to get the tablets, you pick one by one, you go to the scale, measure the weight of each of those tablets. Okay. When you weigh, you take note of the weight. And then after you have weighed, you are then going to find the average weight. Okay. So how do you find the average weight? You sum, you get the sum of the weights that you had gotten and divide by the total number of tablets. Then you can then get what we referred to as the standard deviation. Okay, this is not part of the notes, you must write. So you are going to get the standard deviation. So you have to look at how to calculate the standard deviation. You must have those basic mathematical principles with you. But if you are using an Excel sheet, it is also very easy. You simply highlight the numbers that you are looking at, and then you can put brackets, equals. If you type STD, you are going to have an indication of standard deviation, and you click on it, and you can automatically get the standard deviation. So let me see if I've got an Excel sheet I can use to demonstrate what I'm talking about here. Do you guys know how to calculate the standard deviation? Does anyone know? Anyone?
Let me try, sir.
Yes. As I look for.
Yes. This is where you.
Something I can use.
This is where you need. The formula would be like you need to add the two percentages, and then you divide them. You subtract the 2 percentages, and then you divide them by the same 2 percentages where you add them, and then you multiply them by 100. Yeah.
Okay.
Like
thanks for that input. The computer is also freezing. Okay, I need to demonstrate this using the Excel sheet.